Welcome back to the channel. Let's see how we can turn this into that. All right, I have a Jupyter notebook here, and today what we're trying to do is we want to see if we can take some complex data. Well, the data for today is just a simple data that I downloaded from this link here, which is the Penguins dataset. And we want to see how we can generate a visualization, a useful one, and in a different way. All right, so of course, I'm gonna need pandas. So import pandas as PD, and then I will also need seaborn. So import seaborn as SNS. And the first thing I'm going to do is I am going to read the data frame that I have. So the data frame is a CSV file, so we'll use underscore CSV file. And I have the CSV file in a data directory, penguins underscore size. This is the file, CSV file. And we can look at the shape of the file. So we have 344 rows. And of course, we will look at the head file. So we have some species here, as well as the island, the column length, the depth, and the flipper length as well in millimeters, as well as the body mass and their sex. So we have 344 of these penguins. Right. So the idea really here is that to try to generate a pivot table for a couple of these columns here, actually three of them. If you're very familiar with pivot tables in Excel, this is really the same exact idea here that we were trying to implement. And then we want to also generate a visualization for this pivot table that we are trying to do. All right, so and the way we generate a pivot table here is we call a pivot table on our data frame, and we pass three things. We pass the indexes, we also pass the columns, and we pass the values. And each one of these three is going to be a column that we have on the data frame. So we can pick and choose whatever we have. Just make sure that the values that you have here are numbers, so that you have more representation of what you're trying to say. The species here is our index, which is going to be our rows, and then the island, as an example, is going to be our columns, and the flippers as our values. It doesn't really matter. You can choose whatever you like. If you run this, then we'll see what we find as the aggregation. The default aggregation on the pivot table here is the mean, but of course you can override the default of whatever aggregation you like. The non-values here are for those intersections that do not exist, right? So there is no Gentoo that live in Torgersen Island, for example, and so on and so forth in this data set. All right, so I will put that as data frame pivot table, data frame underscore P, and then all right, so and the last step here is to call Seaborn and then call heat map. And inside the heat map, of course, I am going to use my data frame. And if I run that, this is what I'll see. I don't like the colors. Maybe we can, was it C? Yeah, C map and yeah, cool wall, cool wall. Yeah, I think cool. Yes, exactly. Right. So what we see here, the species as rows, the island as column, and you see the values of the flipper length. Of course, you can add title and whatnot and everything to your plot here. But the idea here is that now you have this color coded with gradients in a heat map that can easily be presented to other people. And of course, traditionally, You can use scatter plots and histograms for almost the same purpose. But I like heat maps because heat maps allow easy comparison of values across different categories or different dimensions, as we've seen here on this plot. And also because they can effectively display large data sets. If you have a large data set, aggregations are better than having a scatter plot full of data points, as we see in large data sets. But more importantly, I like heat maps because they are more effective for presentation and reports, especially if you are dealing with a variety of stakeholders. I hope you liked today's video. Stay tuned for the next one.